My name is Malia Vick, and I'm a junior at St. Trace High School.
My name is Ozzy Deddy, and I'm a junior at St. Trace High School. This project observes the impact of light intensity on broiler growth.
The purpose of this project is to determine if raising chickens with two different light intensities will affect their overall weight. Two groups of chickens were raised, with pen 1 being raised with 1,500 lumens of light and pen 2 being raised under 3,000 lumens of light. All other variables were kept the same. The feed and water was equal and at the same time over the 90 feeding period.
Our problem is that the amount of lumens broiler chickens get when raised, will that affect their final weight?
We hypothesized that pen 2, which used the 3,000 lumens of light, would yield larger chickens. We hypothesized this because it is commonly stated that more light inspires more active birds and therefore they eat more.
The materials we used were heat lamps, watt meters, chickens, a shed, waters, feeders, feed and water, a scale, and a chart.
To conduct this project, we purchased the chickens and raised them together for 4 weeks under the same light and same conditions. During the 4 weeks, we constructed a barrier to separate the two pens and ensure light does not overlap. We connected the lights to a watt meter to record the kilowatts per hour. After the 4 weeks, we separated the chickens into equal groups of 15. We moved the chickens into the separated pens, with pen 1 having 1,500 lumens of light and pen 2 using 3,000 lumens of light. We took the average starting weight after removing the chickens. We continued to raise the chickens, keeping the conditions the same besides the light intensity. They are fed and watered daily, and the bedding was changed once a week. After 5 weeks, the chickens were processed. We took the average weight of the chickens after processing and compared the two pens.
Our control variables are the types of chicken, the types and amounts of feed and water, the temperatures, and the number of chickens in each pen. Our independent variable is the number of lumens each pen was raised in. Our dependent variable is the average weight of each pen.
After analyzing the data, we found that the pen 2, which was raised with 3,000 lumens of light, was 197.2 grams higher than pen 1, which was raised with 1,500 lumens of light. Pen 2 yielded an average of 2,972.6 grams per chicken, and pen 1 had an average of 2,775.4 grams. Here's the average starting weight of pen 1, the average starting weight of pen 2, and the difference between them. The average ending weight of pen 1, average ending weight of pen 2, and the difference between them. And this is the amount of growth for pen 1, pen 2, and the difference between them.
Here's a graph showing the starting weight between pens 1 and 2. Pen 1 started off with 675.2, and pen 2 started with 681.7. Here's a graph showing the weights after processing between pen 1 and pen 2, pen 1 having 2,775.4 and pen 2 having 2,972.6. Here's a graph showing the starting weights between pen 1 and 2 and the finishing weights between pen 1 and 2.
In conclusion, our hypothesis was supported by the results of this test. We hypothesized that the pen 2, which was raised with 3,000 lumens of light, would yield larger chickens on average. Based on our results, it shows that the broilers raised under the 3,000 lumens of light were 197.2 grams larger.
It costs around $2.06 per pound of fresh chicken, and it costs around 17 cents per kilowatt hour. Through our research and experiments, we have learned that there is about a 197.2 gram difference in the ending weight between the 3,000 lumen chickens and the 1,500 lumen chickens. That is equivalent to about 89 cents per chicken. The 3,000 lumen light used 19.173 kilowatts per hour, and the 1,500 lumen lights used 8.649 kilowatts per hour. It costs about $3.26 to run the 3,000 lumen light for 824.25 hours, and it costs $1.47 to run the 1,500 lumen light for the same amount of time. Overall, pen 2 cost $1.79 more to run, but yielded about $13.35 more.
This information can be valuable for farmers raising large quantities of chickens. By looking at this project, they can decide if they wish to use more money to pay for higher watts and in return gain more money from their chickens. Or if they want to pay less money for their watts and raise chickens that will sell for less.
We would like to thank our FFA supervisor, Jennifer Johnson, for overseeing this project and allowing us to the access of the bond, which was essential to our experiment. We'd also like to thank John Scott for being our adult sponsor and helping us successfully complete this project. We'd also like to thank Charlie Klein for taking this video and providing guidance and wisdom.